Okay, we will discuss about what we have done so far and express it in the title, a review of the use of spores for the supply of high quality red algae Kappaphycus alvarezii seedlings. Several researchers pointed out that various advantages of using spores as seeds in the seaweed cultivation industry, especially those belong the red algae. This statement was mentioned already by Glenn et al. In 1996, Costamo in 2008, Mantri et al. 2009, Forbor 2020, and Suda and Mikami in the year of 2020. Methodology. These studies on the effect of salinity, temperature, light, color, type of artificial substrate on spore release and development were carried out in 2013 and 2014 of the year, conducted at the Wet Laboratory, Faculty of Marine Science and Fisheries, Hasanuddin University. Further experiments on growing spores into adult plants in the sea were carried out in the following year. That is in the year of 2015, conducted in the coastal waters of Jonggoa, North Galeson District, Takalar Regency, South Sulawesi, Indonesia. Cystocarp of Kappaphycus alvarezii we use as the material for seedling, as you can see in the figure. You can see here the cystocarp of the Kappaphycus alvarezii. That's the cutting of the thallus that we have to use. This is the setup of the experiment. The figure at the left is setup of the water salinity level experiment. At the right, and the right side is the setup of the water temperature experiment. Here, at the left side, you can see setup of the light color experiment, and at the right side is the substrates materials tested for the attachment of the spores. Experiment on releasing the spore, then continue growing to seaweed seed in the sea. Here there is a bottle, water mineral bottles covered with net, and we inserted the thallus consisted of bearing a cystocarp inserted between the bottle and the net. Then the bottles further hang at the angle of the raft. The raft made of PVC pipes, as you can see it here. Okay, let us see the result. Apparently, we use tetrasporophytes at the above, figure above, and the carposporophytes below it. The spores the figure of the spore we recorded. You can see it here, spores. This is the tetraspores with protrusion. That's what we have recorded picture. And this is two pieces of multicellular disc, carpospores. Then below it, the early formation of primary prostrate disc of the carpospores. Let us see the effect of different salinities on spore release. The spores were released at salinity of 20 ppt, 25 ppt, 30, 35, and 40 ppt. But at a salinity of 30 ppt, spores were released on day 20. And at 20 ppt salinity, spores were released on day 24. And at 35 ppt salinity and 40 ppt salinity, spores were released more rapidly. That's occurred on day 3. Now, how development of spore to plant? At 35 ppt, the spore developed into plantlets more quickly. That's on day 13, then added salinity. Then, grew thicker. The diameter of the branches was getting bigger on the next 20 days. That is mean at day 15. As De Miranda et al. In the year of 2012 noted that maximal growth of the red algae spores, that the species Hydropuntia caudata, become plantlets at 35 ppt. At 30 ppt, plantlets were formed on day 30, and at 25 ppt, plantlets began to grow, formed on day 15. At 40 ppt, spore didn't develop into plantlet until the end of the study. And what the author said, De Miranda et al. In the year of 2000 said that the maximal growth of the red algae spores Hydropuntia otundata became plantlets at 35 ppt, and their development was imperfect and very slow at low salinity. Low salinity can cause morphological abnormalities of the spore cell walls, including becoming thinner due to lack of calcium, which is the constituent element of the cell wall. That is what De Miranda et al. Said. And let us see how development of plantlets to young thallus. Young thallus began to form on day 24 at salinity of 30 to 35 ppt. The thallus developed further with more thicker and longer thallus. This is, we talk about different effect of different salinities. You can see here some form, some picture of plantlet at the left side. For picture at the left side, it's a picture of plantlets, figure of the plantlets, and the right side is figure of the young plant thallus that's developed from plantlets. So plantlets develop to young plantlets, to young plant or thallus. And let's see the effect of different temperature on the spore release. At the temperature of 27 degrees centigrade, 29, 31, 33, and 35 degrees centigrade were able to cause the release of spores. But at 33 degrees centigrade to 35 degrees centigrade cows, the spores were released earlier. That's the day at the day 1. Further, at the temperature of 31 degrees centigrade, the spores were released on the day 3. Then, at the temperature of 27 degrees and 29 degrees centigrade, spores were released on day 8 and day 9 respectively. As reported by Lonas and Robledo in 1999, the release and development of spores can be delayed or slow due to suboptimal temperatures. In this case, 27 to 29 degrees centigrade in this particular experiment. Let us see the development of spores to plant. What's the effect of temperature? At 35 degrees centigrade, this is the best temperature for the development of spores into plantlets, which have been formed on the day 12. And at 31 degrees centigrade and 33 degrees centigrade, the plantlets were formed later, namely on the day 15 and day 16 respectively. And let us see release of spores and development to plantlet at different light colors. Spores were released in the light of green, blue, red on the day 5. Plantlets were formed with white, yellow, blue, red on the following day 5. Then more plantlets formed in the red light, but none with green light. This is all photosynthetic electric radiation, as stated by Salisbury and Rose in 1995, has energy and effectively absorbed by plant cells, including red algae seaweed, in this case Kappaphycus alvarezii. Last but not least, experiment on the development of spore to seaweed seed in the sea. You can see that spores already grow to thallus here at the left side. There are 3 figures at the left side, and then further 4 weeks after cleaning the substrate, because there are some seal particle attached on the bottles, so we clean it. Then after 4 weeks after cleaning the substrate, the thallus grow with more branches. Yeah, you can see here around 0.5 kilogram per hour, and then further 16 weeks growing, the thallus are straight, supple, with shiny and bright colors. This is indicate is a good quality of seedling. Yeah, that's all. Thank you very much. If you have some suggestion or question, be open to discuss together, to answer whatever you question about. Thank you very much. See you again. See you next.